later, I told him. Motion with changing velocities. Oh, let's add my favorite student here, good old Anne. For those of you that were away, you can mark this at home. Match the following graphs. So all of these are position time graphs. Whenever they give me a graph, Amelia, the first thing I do is I check out the y-axis and the x-axis. I want to know what I'm looking at. So these are position or distance or displacement time graphs, which represents an object which traveled at constant speed and then changed speed, stopped for a while, and continued at a second speed. Went at a constant speed, sped up, stopped, and then continued at that same sped up speed. Sure. What are we really talking about? What's the key idea? Where does speed or velocity appear on a position time graph? One word begins with the letter S. Slope. And then think steeper or shallower, faster or slower. Curved means changing speed. Line means constant speed. Horizontal line means a slope of 0, a speed of 0, you're at rest. Change to a lesser second speed. A. Stopped. B. So one cab, CAB. Ooh, now we got some curves. Which graph represents an object whose speed decreased gradually? Where does speed appear on a distance versus time or position versus time graph? One word begins with the letter S. So what I really see is I'm looking for a slope that's decreasing gradually. Right? Increasing gradually. You're speeding up. Increased gradually, then decreased gradually. Sped up, started slowing down. Turn the page over. Match the following graphs with the descriptions below. The object's speed decreased to 0, then increased again as the object returned to its starting point. The object's speed decreased to 0, then increased again as the object returned. Oh. Decreased to 0. I'm not so wild about that one. You know what? Maybe we're looking at decreased to 0 for a split second right there. If we drew our instantaneous slope by laying a ruler down, I think it's horizontal. Oh, and then it returned back to its starting point, which I guess would be position 0. You guys agree with me? I think it's got to be C, and I'm not quite wild about that. By the way, I was doing the computer graphics, and they're harder than you realize. So getting these, I couldn't quite get this thing to clearly, anyways. And after half an hour, I gave up and just said, fine, it's going to look like what it looks like. Object traveled at a constant speed, straight line. Stopped for a while, then returned to its, you know what? That's A. That's A. This object traveled at a constant speed, then moved back and forth. Forwards, backwards, forwards, backwards, forwards. Yep, that's that one. Can you give yourself a little score out of 9? So quiz 2, in fact, I'm not a big enough fan. I'm actually not going to collect quiz 2. You can mark it. And in fact, number 1, solving, we really did that last unit, so meh. Okay, and also I've noticed that I forgot to put the scientific notation exponents in like an idiot, and so I apologize, whoops, but I'm going to nuke number 1, and we're not going to collect it anyways, and if you did it, great, but whatever. Number 2, sure. I will ask you a frequency question. Now we talked about frequency and period. Frequency is how many per second. In this case, how many dots per second. The frequency is going to be 225 dots per 5 seconds, if you want to actually look at the units. 225 divided by 5 is 45. This frequency is 45. Hey, what were the units for frequency? Hertz. Capital H, lowercase z, but if you wrote them both lowercase, I won't freak out. A recording timer makes 625 dots in 10 seconds. What's the length of time between each dot? By the way, what this is really asking for is the period. The frequency would be 625 over 10. The period is going to be 10 over 625 because they're reciprocals of each other. If you know one, you know the other. 10 over 625 is going to be a pretty small decimal. Might work out to a nice decimal, though, I think. 0.016. Every dot occurs every 0.016 seconds, which is kind of a dumb measure, but I was just making up numbers, and that's in seconds. Number 4, a car travels 40 kilometers in 30 minutes. What's its average speed in kilometers per hour? Kilometers per what? So I could do this as a full unit conversion. Don't write this down. I could go 40 kilometers in 30 minutes, and then I could say, okay, I want minutes to cancel, and it's on the bottom in the first fraction, so I'll put it on the top, and I want hours on the bottom, and I could say 60 minutes is 1 hour, and I could do it like that. Or, I think most of you know, 30 minutes is what fraction of an hour? Yeah, the real fast way would be to say, you know what, it's going to be 40 kilometers divided by half an hour. It's 80 kilometers per hour. And if you did it that way intuitively, good. But for what it's worth, our chain method from from the whole unit analysis works. 80. Yeah, there's all sorts of ways. You could say, you know what, if I got 40 kilometers in half an hour, I'll get 80 kilometers in a whole hour. There's many intuitive ways to do it. It took me 30 minutes to get here, traveling an average speed of 80 kilometers an hour. How far did I travel in meters? Now, if you were really clever, you would have noticed that this is the same answer from number 4, and this is the same time from number 4, and so you might have just said it has to be 40 kilometers because that's what it was in number 4. Anybody, you notice that? No? You did? Oh, you caught it? Okay. Anyways, for what it's worth, if you wanted to do it mathematically, you could say, okay, what we're really talking about was this equation, which is not a very good equation because it doesn't deal with acceleration. I'm not a fan of that. It's the one they give you in Science 10, and I hate it because it means you're traveling at a constant speed, and that's boring. Anyways, it's going to be 80 times half an hour, 0.5. It still is 40 kilometers. 40 what? Oh, in meters. 40,000. Read the question, Dueck. Meters, because a kilometer is 1,000. Thank you. The only question that I really do like on this quiz, you're going to see something on your test like number 6 where I'm going to ask you to find an equation. Okay. My template is this. Oh, I can fill in B, apparently. And, oh, instead of X, the variable is going to be T, and instead of Y, the variable is going to be D. Slope. Slope is what over what? Rise over run. So it looks like I'm 40 high here, I'm 12 high here. I think if I go rise over run, it's going to be 40 take away 12. If you want to actually do the math, it's going to be 28. And I think my run is from 5 to 24. It's going to be 24 take away 5. I think it's going to be 28 over 19. Is that right? It's going to be 28, and I deliberately made up yucky numbers on purpose. 1.473, you know what? I'll go 1.47. If you left it as a fraction, that's okay as well. If I was marking this, I'd probably give you half mark for the correct slope, half mark for the correct y-intercept, and then I'd probably take a half mark off if you used y and x instead of d and t, something like that. But I'm not going to collect this one. Last day, we introduced, or we started working, or we continued working with the constant acceleration equations, and I gave you some homework. Can you get out the homework from lesson 5? And this is your chance to ask me questions. Today, we're going to look at a couple of applications, and then I'm going to shut up for a while and give you a whole bunch of these to practice. So lesson 5, we started off with a graph. In fact, number 1 is very, very, very similar to the question we just did on quiz 2, except this time it's a velocity time graph. Anyways, were there any of these that you were looking at the answers and you were saying, I have no idea how the heck they got that? You folded everything up for some strange reason?
No, it's just started.
Okay. Now, I'm getting a sense some people haven't done the homework, a little grumpy bearish. Okay? Because usually kids ask me questions. If you haven't done the homework, I'll still take questions on this next class, but we are going to move on a little bit. You're going to want your yellow formulas sheet visible, please. If you have lesson 5 done, hand it in. What I want to talk about, lesson 6, I called it applications of acceleration. I want to show you 2 cool applications and then probably my favorite application, which is free fall, jumping out of an airplane, which I've done, by the way. So, lesson 6, applications of acceleration. And I wrote here, remember DFIC. Remember, list your data, find a formula, insert, and crunch. I wanted to show you where this is actually used out there in quote-unquote the real world. So here's example 1. I looked these numbers up. A jet airliner needs a takeoff velocity of 288 kilometers per hour in order to safely leave the ground. The jet's engines can accelerate the jet forward at 3.5 meters per second squared. How big a runway do you need to build? So you're an airport designer. These are the specs. I think I pulled these from a 747, but I can't remember now. But I Googled a couple of the major jets and I got these numbers. You're designing an airport. How long does your runway have to be? So, ready? What's this question asking me to find? Let's write down D equals question mark. What else do I know? So now we start reading, and we're looking for numbers with units, and also physics words like at rest or stopped or constant or something like that. What's the first thing you, yeah? The question didn't tell you this, but I'm making the assumption that all of you have been on an airplane. Every single jet for a split second comes to a stop. So Colin, good catch. I won't tell you that, but yeah, VI is 0. They don't turn the corner and keep going. I don't think they're allowed to. Sorry, what was your next comment? VF is what? 288 what? I don't like that. The units are yucky. The units are yucky. All right? There is a way to do the conversion. Have I given you guys the shortcut to go from kilometers per hour to meters per second? It's times or divide by 3.6. I know it's 3.6, and that's the number you want to memorize. Is it times or is it divide? And I'm going to show you a way you can figure it out every time without actually having to memorize everything. I'm going to pick on Carson. Carson, I have no idea for 288. I'm going to pick an easier number. The speed that you go on the freeway, the nice round number that you go, not on the highway, on the freeway. What's the speed there?
80.
No, not on the highway, on the freeway. The nice round number. 100. You've been on the freeway before. Okay. On the freeway, it's 100 kilometers per hour. If I times by 3.6, in your head, what's 100 times 3.6? That would mean that you're traveling 360 meters every second. That would mean when you're on the freeway, you're passing 3.5 football fields every second. Have you been on the freeway? Are you passing 3.5 football fields every second? Look out the window. Use your imagination. Are you passing 3.5 football fields every second? Thomas is correct in shaking his head. You don't times. So if I don't times, what do? I do that, by the way. Anytime you give me this conversion, you're going to see my eyes go blank. I kid you not. I'm on the freeway. I'm at 100 kilometers an hour. I try timesing it. And I don't pass 360 meters. That would be 3.5 football fields every second. No, I don't go that fast. I've looked out the window. That would be a blur. I've looked out the window. So it's not times. You know what it is?
Right.
Now you can memorize that, divide by 3.6, or I've shown you a way that you can, with a little bit of thought, Riley, derive it. This is what I teach my Physics 12 kids as well. Whenever we have to do this particular unit conversion, they all know, is it times by 3.6 or divide by 3.6? Freeway, 100, times doesn't work. Divide. So anyways, divide by 3.6. Can you do that to get me meters per second? Let's do that. 288 divided by 3.6. And I get, oh, nice, 80 meters per second. You okay with that? Colin, what else did they tell me you were giving us? Okay. What's the acceleration? 3.5. So, you may have noticed, and I've mentioned this, the pattern, Jordan, is if I know 1, 2, 3 things, I can find the fourth. So I'm looking for an equation, has to have D, VI, VF, and A. Oh, what don't I know? Time. So don't give me one that has time in it. This is the skill that we need to get good at. If you can't find the equations in the first place, I can't help you with the rest of this. If you can find the equations, I can teach you everything else. So on the yellow sheet, which equation has D, VI, VF, and A in it? Okay. You've got to be able to find, let's write that down. VF squared equals VI squared plus 2AD. There's step 1. And in fact, that's the skill you're going to be practicing today. I have a sheet with a bunch of these. I don't even have any words. I just have the numbers, and it's finding the equations. It's that important. What are we trying to find? See it? This. Now, here's the next skill I'm nudging you towards. I am nudging you towards less memorizing, a little bit of thinking. It's a better way to go. We want to get the D by itself. What side is the D on? See it, see it, see it? Okay. So I'm going to move everything that's not a D to the left. There's already something on the left. The VF squared is going to drop down like a domino. So drop it down. What else is next to the D? A 2A? What's the 2A doing to the D? So how will I move it over, Kyle? Last. There's also a VI squared. What's the VI squared doing? How will I move it over? So it's going to be subtract the VI squared. By the way, I know VI is 0 and I could cross it out, but I'm showing you the general method if it wasn't 0. And then what did you say I'm going to do with the 2A? And by the way, if you forget, you can figure it out by looking. Oh, do the opposite of what's being done to the variable, right? Is that equation on your formula sheet? Nope. Will it be on your formula sheet? Nope. I don't need to. Do you need to memorize it? Please don't. Please memorize how to derive it. I kid you, I had one kid who'd memorized every single one in her Physics 11 year. I never taught her in Physics 11. And then in Physics 12, she tried to continue, and by about November, she collapsed and broke down. And, okay, Mr. Dueck, I'll learn to rewrite these. It's better. So, list your data, find a formula, insert the numbers. 80 squared minus 0 squared. I probably won't bother typing the minus 0 squared on my calculator, but I'll show it there so you know that it was okay. All over 2 times 3.5. Kyle, I think you were the one that I asked last day. Is there more than one number on the top? I should put it in brackets. Is there more than one number in the bottom? I should put it in brackets. And now, since my technology is working, I can show you what it would look like on your calculator. I would go, especially if you have a good calculator, not a cheap POS like I've been yelling at you about, bracket 80 squared. Will the minus 0 squared change anything? Okay, then I'm not going to type it, but if I needed to, I would if it was not 0. Divided by bracket 2 times 3.5. How long must this runway be? How many meters? Do you get 914? By the way, that's in real life a garbage answer. That's minimum length, assuming you back your plane up so that the back wheels are right on the edge of the pavement, and then your front wheels are right on the edge of the far pavement when you're taking off. I'm sure they'd triple it, right? They'd put on a huge safety margin. But certainly they wouldn't build it any shorter than that. You can't. So this would be, I'm sure, somewhere in an airport design. They have this somewhere. Or they might have charts where they just got it all figured out for the people already, but we've done the math. So there's a neat application. I can use it to predict how much distance I need if I know a certain speed. Replace airport with drag strips or race cars or whatever, and you can start to see why the infrastructure is built the way it is. Hey, let's look at some accident investigations. RCMP. Example 2. An RCMP officer is investigating a car crash. At the scene of the accident, there are skid marks that are 32.5 meters long. Measure that with a tape measure very easily. And in this day of distracted driving, it turns out the driver of the car was speaking on a cell phone during the accident, and the cell phone records the sound of the skid for 1.2 seconds. The speed limit on the road was 60 kilometers per hour. The driver says, I wasn't speeding. Can the RCMP charge him? Ooh. Let's find out. And again, whether you think yes or no, let's prove it. This would be admissible in a court of law. All right. This one's a bit trickier. What's this question asking me to find? A speed, which one? A velocity, which one? Why do you know it's not V final? What is V final in any car crash? Okay, I'm not going to tell you that. If I give you a car crash question, Thomas, I'm going to assume that you know in every car crash, V final is 0. Fair enough? So let's write that down. VI equals don't know. What else have they told me? Hopefully you saw the seconds and said, it's got to be time. It's, again, as much as I don't memorize garbage, it's well worth memorizing what units go with what quantities. What else? I'm looking for an equation that has VI, VF, T, and D. I guess it can't have A in it. And you can either go divide by 2, or that's the same as having a half here. They're both interchangeable. You read it this way, so I'll go this way. Okay. What are we trying to get by itself? Now, remember, Spence, when you're solving an equation, it's actually reverse bedmass. And what I mean by that is you take care of what's inside the brackets last, turns out. So you ready? Here's what I want to get by itself. What's right there? What's the T doing to the bracket? Multiplying? How will I move it over? What's right there? What's the 2 doing to the bracket? How will I move it over? So the first thing I would have is this. Don't write this down just yet. I'm going to start writing, and then we're going to see if we can do the whole thing in our head. But right now, the D would drop down or like a domino. You said I would times by 2. You said I would divide by T. Don't write this down yet. And what that would leave me with is VI plus VF. Don't write that down yet. What am I trying to get by itself? How? You can write that down. Is that okay? And if you can do that all and keep track of that in your head, I say good. If you can do that, Nick, without showing work in your head, that's becoming an expert. That's a good thing. Wait a minute, I thought math teachers always wanted me to show work. I'm a little different. I really, really want you to master this, and I think it's a good enough shortcut that I'm willing to assume you didn't cheat and copy off someone else. I'm willing to assume, Thomas, you were able to rewrite it in your head. And if you can't, you'll get there. By the way, I guess I could have done this because VF is 0, but I just wanted to show you that we can rewrite that whole equation even if VF isn't 0. So I get VI is 2 times 32.5 divided by 1.2. Good morning, sir. 2 times 32.5 divided by 1.2. What do you get? You get 54.2 units. Okay, 54, what did I say? 54.2 meters per second. I need to change that to kilometers per hour. I'll give you a hint. It has something to do with the 3.6. And I'll give you a hint. It's the opposite of going from kilometers per hour to meters per second. So what am I going to do? What? Okay, this guy's full of it, right? He's not only going to get charged, he's probably going to get criminally charged. He's going to lose his license. Also, by the way, this is the minimum speed he was doing. Is it possible that he slowed down before skidding? Yeah, he could have been going faster. This is, he has to, based on that physical evidence in a court of law, he has to have been going at least that fast. That's the only explanation for that data. But he could have slowed down before he started to skid. Okay? So if you were a plaintiff in this situation, you're out of luck. You got no argument here. No argument here. Now, I fudged things a little bit because in real life, hey, Mr. Dueck, what are the odds that the cell phone would pick up the skid mark? Fair enough, but as we get better, you can actually analyze accidents with less data than this and come up with the same kind of proofs and say, okay, you know what, you're going to get charged. I like this question. I like this question. I like this question. This is a neat question. A, because it's kind of cool, but B, good application for stuff we've done so far. And you know what? I like example 2. I like example 1. I like example 1. Example 1 is a nice question. Free fall. Free fall. Acceleration and free fall. Near the Earth, objects in a vacuum all fall to the Earth with the same acceleration, regardless of their mass. Mass. Wow, that was a tough word to say. Put your pencils down. That's a very profound statement I just said. Acceleration. Regardless of their mass. Pick your hands up. We use the letter lowercase g to represent the strength of the Earth's gravitational field. And it turns out near the Earth, g is negative 9.8 meters per second squared. That's the acceleration due to gravity. That's also called the Earth's gravitational field strength. This is the Earth's gravitational field strength. Outside of a vacuum, air resistance for a feather or for a piece of paper can dramatically lower G. But we're going to ignore air resistance most of the time. In fact, if I'm talking about dropping an object, unless I say different, let's assume it's this thing. Nice and round, aerodynamic, and heavy enough that air resistance really isn't going to play a big role. Okay? Example 1, a cannonball is dropped from a cliff. It hits the ground 5.6 seconds later. like you all to underline the word dropped, please. This is going to be a physics word as well. If I drop something, what's my initial velocity? 0. I'm not going to tell you that again. I won't say that in the question, but if you see the word dropped, you are allowed to assume, oh, what else has this question told me? T, 5.6. The other thing, when you see the word dropped, Jordan, you know the acceleration. It's negative 9.8. Why negative? Down. You're speeding up, going downwards. I will not tell you that. If you're in free fall, if you're dropping an object, you can just, hey, write that down. What's this question asking me to find? What is, sorry? Ah. Can you find for me an equation that has D, VI, T, and A? And I guess no VF. Alexa, get the headphone out of your ear. Please. Thank you. What equation?
D equals VI T plus 0.5
A half.
half A T squared.
Yep. We need to get the D by, oh, ha! D's already by itself. That's convenient. Oh, why can I do that? VI is 0. So what's VI times 10? What's 0 times 10? 0. What's 0 times a million? 0. What's 0 times T? 0. Cancels. Okay. How high is this cliff? It's going to be, now I'll change it to a 0.5, Spence, times negative 9.8 times 5.6 squared. What do you get? You get negative 153.664. Okay. By the way, how many sig figs? I see that 5.6 has 2 sig figs. I'm going to go negative 150. I'll go to 2 sig figs. Why negative? Well, actually, we didn't find the distance. What we actually found was the displacement. When you drop something, does it end up above or below from where you started? Below. How could I show below mathematically with a displacement? Negative. It's saying, oh, by the way, you ended up below from where you started from. So that doesn't surprise me. I'm okay with that. Now, if you said the cliff is 150 meters high, I'd accept that because Thomas height is a scalar. But for what it's worth, I kind of like the fact that the negative pops out. It's telling, but you've done the physics right. You did end up below. I like that. B. What's B asking me to find? The final. Now, a common mistake when I say what's the final velocity, kids want to say, well, 0. No, that's after it hits the ground. Whenever we drop something, if we ever drop something and I say find the final velocity, what I really mean is that one, right at impact, not now, after impact. So I'm looking for an equation that has V final in it, and then it can have VI, T, A, and maybe D, but I'd prefer not to use D because I just calculated it. Is there one? There is. Which one?
VF
Yeah.
VI plus AT.
Okay, I need to get the VF by its, oh, ha, already is. Oh, and I can do, because VI is. So, it's going to hit the ground. By the way, when it hits the ground, which way will it be traveling, up or down? This is meant to be really obvious. Down. So should I get a negative or a positive velocity here? I'm expecting a negative velocity because that's down. In fact, I should put the vector sign on this thing. Let's see if that works. It's going to be negative 9.8 times 5.6. How fast is it going at impact? And I get negative 54.88. Or if I go to 2 sig figs, I guess I would round that to negative 55 meters per second. What's the negative telling me? Down. By the way, don't say negative 55 meters per second down, because negative down is technically up. Either say the word down without a negative, or it's easier just to put a negative there and I'll clue in and it's less writing. We're going to practice free fall actually some more when I see you guys next on Friday. But what I have for you is a sheet of lots of practice. Can you take a look at this? I called it using the constant acceleration equations. I put them at the top, but they're also on your yellow sheet. All I did, if there's one skill that I found hampers kids in mastering this, it's I can't find the equation. And so, Thomas, all this is, and yeah, it's a bunch of them, is I've given you a bunch of the data. That I've done the DFIC part. Let's find the equation. And practice getting the variable by itself, which is a little bit trickier. Number one, what are they asking you to find? VF. I've given you VI, I've given you A, I've given you T. Those ones aren't too bad. I want to turn to a bit of a yuckier one. Let's try, how about number 10? Can you look at number 10, please? What are they asking you to find? Okay. Which equation can I use? So you're hunting for an equation that has A, T, and D in it. Yep. Let's write that down. We'll do number 10 together, and then I'm going to shut up. Plus a half AT squared. This is about as tough a formula to rearrange as it's going to get, which is why I did this one on purpose. What are we trying to get by itself? Thomas, this bad boy right here, right? What else is next to it, Thomas? How am I going to move the T over? Later. Always do that last. What else is on the same side? A plus a half AT squared. How will I move that whole thing over? What's it doing? I'm going to minus it. I'm going to get this. D minus 0.5 AT squared. That equals, don't write this down just yet, VIT. What did you tell me I was going to do to move the T over, Thomas? Okay, you know what? Hey, there's another equation, not on your formula sheet. I'll let you take that one the rest of the way, but I wanted to show you that. And then there's one more I want to do. Let me go hunting for it. It's one where we're looking for T. Yes, number 12. Number 12. What are we being asked to find in number 12? Time. Okay, can you figure out which equation we're going to be using? Same one? Oh, okay. By the way, that's actually a really important one, especially in Physics 12. I can't flog it to death quite as much in Physics 11 because you don't have the math scale. It's a quadratic, and you guys don't know what that is yet. Anyways, you might. Same one? However, I was nice. One of these values is 0. Which one? Okay. Right? So if VI is 0, Noah, this equation modifies into D equals AT squared, and there's a 1/2 in front, but Spence, instead of putting a 1/2 in front, I'm just going to say that's the same as dividing by 2, because that looks, honestly, cleaner, prettier, nicer. We're going to be using this one an awful lot, so you can even put a little star next to this particular trick. We're going to be solving for time using this equation very, very often. Oh, what did I say we're solving for, Max? T. What else is next to the T? How would I move it over? Divide. What else is on the same side as the T? A 2. How will I move it over? Now, here's what you're going to end up with. 2 times D over A equals T squared. We're not done. I've got a T squared. So here's my question of the day. How do I get rid of a squared? Holy smokes, square root's actually useful? Yeah. What I do is I always write this, then I scribble that out, and I put a big square root. That's my way of saying square root. It's going to be 2 times D divided by A. Get an answer on your calculator, hit equals, and then square root that. I haven't done an example like that, but I'm going to see if you can figure it out. The rest of the class is yours. You'll get some time to work on this also next class, but try and go straight to the, yeah?
Do we have to solve, or are we just manipulating equations?
I want the actual answers, because you're going to find at the very, very bottom, you'll see the scramble. Your answers should appear down here somewhere. You can cross them out along the way as you go if you want. Yeah, I want the full solve. Oh, I did proper sig figs, so if you can't quite find your answer, check your sig figs, and it might be rounded off. Is that okay? I'm shutting up.